So good morning, everyone. Welcome to this session on the VESPA framework. So my name is Marc Lacoste. I'm a senior research scientist in Orange Labs and in the security department. And together with my colleague Aurélien Wailly, we're going to show you this morning how you can make your cloud self-protected with the VESPA solution, which was developed as part of the OpenCloudware project within the OW2 software open source initiative. So the agenda today will be the following. After a bit of motivation and tell you about the approach, we will tell you about VESPA principle and architecture, illustrated by a typical use case. And then we'll say a few words about the VESPA project and conclude by some perspectives and key takeaways. So, what's wrong with current IaaS infrastructure today regarding security? Mainly, there are two barriers which have to be overcome regarding security. The first barrier is proliferation of threats, since we have threats which target vertically on the system side the different layers on the infrastructure, which mainly security components which protect the layers only, and which are very difficult to reconcile while the attacks span the different layers. And horizontally, the problem is the same. We have very security components which protect domains, while the attack may span the different domains throughout the network. So we have the problem of achieving end-to-end security. And for this, we want strong security with integrated security monitoring, and in addition, we have to achieve a security architecture which is open in order to face threats which are both known and unknown. The second barrier is complexity of security management. Since security management and administration is achieving isolation, is configuring security components, often manually, and everything of this operations very complex, very static, and very little efficient. So what we want is very simple security in order to have easy administration and an efficient response in terms of security. So our approach to face these challenges is to make the cloud self-defending. So self-protection has been advocated as a very promising approach regarding the next steps for more simpler and stronger protection regarding clouds. So it consists in orchestrating a number of autonomic security loops with detection, decision, and reaction steps, and with a number of well-known benefits in terms of lighter administration, increased reactivity, lower operational costs, and graduated response. So what is VESPA? VESPA stands for Virtual Environment Self-Protecting Architecture. And this framework, developed in the OpenCloudware project in OW2, is an automated security supervision framework for IaaS and multi-data center infrastructure. It's based on the following 4 design principles in order to make a cloud self-defending. First, to achieve policy-based self-protection, to have a well-defined adaptability model. Second, to have cross-layer defense, so that the security may have an overview of the attack throughout the layers and not protecting a single layer only. Third, to have multiple self-protection loops in order to have multiple levels of granularity for monitoring, which may be at the level of a single layer, cross-layer, or multiple data center in order to be able to put in place tunable defense strategies. And fourth, an open security architecture in order to be able to put in place flexible countermeasures in order to be able to face known and unknown threats. So this framework is applicable not only to the customer in the form of security as a service appliances to protect its VM, but also to the cloud provider to monitor its IaaS infrastructure in a number of security use cases for anti-malware, anti-DDoS, and achieving end-to-end security. So the system security architecture of VESPA followed a layered design according to 4 planes, which cross-cut the IaaS infrastructure. So the 4 planes are the following. The resource planes contains the resources to protect, so at the VM level, the hypervisor, or the physical level. The second plane is the security plane, which contains a set of security countermeasures, both for detection and reaction, which may be an intrusion detection system, an antivirus, or a firewall. The third plane is an agent plane, which is a mediation layer between the security countermeasures and the decision-making logic in the orchestration plane. So we have 2 sets of hierarchy of agents, both for detection in order to aggregate alerts to the orchestration plane, and then for reaction in order to carry out and refine the reaction policies back to the security countermeasures. Finally, the orchestration plane is a 2-level set of autonomic security managers, both within a layer and cross-layer. So we have 2 levels of response for security. The first is intra-layer self-protection for reflex, very fast response to a threat. So within, a threat is detected within a layer, goes through the agent hierarchy, and decision-making is taken within a layer, within a horizontal orchestrator, we call it the HO, and then goes back down to the countermeasures within the reaction agents down for enforcement. The second way to achieve security is a wider level, for wider level loop, which is cross-layer self-protection. And in this type of loop, the reaction, the decision-making logic will go up not only within a single layer, but at the cross-layer to the top-level orchestrator. And then once the decision is taken, it will go back down another layer for enforcement, for instance, within the hypervisor. We will illustrate this on a simple use case of risk-aware flexible confinement of VMs. So the principle is the following. We will set up a quarantine zones where the VMs suspected to be infected are identified, and once they are detected as infected, they are isolated and migrated to a quarantine zone for cleaning. Once they are cleaned, they are migrated back to the production environment, reconnected, and everything goes back smoothly in terms of execution. So in terms of instantiation, we have 2 machines, the production environment and the quarantine zone, and 2 virtual machines, an administration VM and a user VM. The administration VM is the decision-making logic. The user VM contains the VM to protect. So we have basically 5 steps: detection, isolation of the VM, migration of the VM to the quarantine zone, cleaning, and then migration of the VM back to the production environment and reconnection. So how is this implemented within the VESPA framework? So the figure here shows which are the components of the different planes for resources, security, agents, and orchestration. I will not go into the details. What you should keep in mind is that you have 3 levels to achieve self-protection. The first is that level can be done only at the VM level to achieve analysis and cleaning by the antivirus, which is within the VM, just for intra-layer self-protection. The second way to achieve self-protection is cross-layer self-protection for isolation of the VM, and here the hypervisor will be involved, for instance, with a firewall component, which may be Neutron. The third way is also cross-layer, but here the VM will be migrated to the production environment, and here the hypervisor will also be involved, but here within the migration manager, which may be the hypervisor, for instance, with the Nova components. Here, the architecture is well adapted to the OpenStack environment and may be extended to other OpenStack services, such as Ceph Glance or Keystone, using dedicated agents for migration. So, regarding the VESPA project, what have we done so far? So, VESPA is a framework which is available in open source, and here, check it out. The code is available on the GitHub. It's a core framework with a number of security plugins. So the features are available here. It's in OW2, available in open source. It's also a research work published at ICAC with a number of extensions for network management using the SDN approach or protecting the hypervisor. There are a number of perspectives to add new features, for instance, an administration console, plugins for IDS or policies, and integrating within OpenStack, such as writing blueprints, extending the Nova, Neutron environment, or even setting up a standalone project. And the next step will be investigated how VESPA can be used for security monitoring of multi-cloud environments using what's called by IBM the supercloud architecture. And this may have a number of applications, for instance, for distributed cloud, for edge clouds, and so on, to have self-managed, self-service security. So the key takeaways are the following. VESPA is the framework for supervising the security of IaaS infrastructures, which fills really a gap among existing OpenStack security solutions. It provides rich levels of security automation, multiple level protection, and a fully open design. So it's compatible with the OpenStack architecture and mechanism, and here we're really looking for taking it to the next level and looking for feedback from the OpenStack community for a way to put it, be able to contribute this framework to the next OpenStack releases. So this concludes my talk, and thank you very much for your attention, and please do not hesitate to contact either Aurélien or me for any question, discussion, feedback, or even question regarding the code. We'll be very happy to answer you, and if you have questions, do not hesitate. Thank you very much for your attention.